before looking at polymorphism again, we know polymorphism means object can have many forms. Like for example, dog can be an animal, fish can be an animal. So we could say Snoopy is an animal and Snoopy is an object of the dog. Which we can also say animal could be Nemo equals to new fish. So both of them are the same object. And how would that happen? Because we have polymorphism through the inheritance of the same class. If they don't inherit from animal, let's say I have car class. So can we say animal Toyota equals to new car? No, we cannot do that, right? Because car is not inherited from animal. We cannot do that. We can only do car Toyota equals to new car. So we cannot do polymorphism through that. But these are polymorphisms because of inheritance. Make polymorphism for you. Because they are inherited from animal. So they are animals. Now in this example on the slide, we want to do the same with the geometric objects. Class and circle inherited from geometric objects, and rectangle inherited from geometric objects. In that case, that means circle is also geometric, rectangle is also geometric. Then we can do inheritance, right? And polymorphisms do that. Now what is polymorphisms? So if you look at the concept of polymorphisms, means that a variables of a supertype can refer to a subtype object. So a class defined a type defined by a subclass is called a subtype, and the type defined by its superclass is called a supertype. So in this case, subtype is a dog, right? And supertype is an animal. Subtype is a fish, and supertype is an animal, right? Therefore, you can say that for the circle is a subtype of geometric object, and geometric object is a supertype for the circle. So we create a polymorphism code here with a circle. We call circle from simple geometric object because it's extend from simple geometric object class. And we also create a rectangle from geometric object because it extends from simple geometric object class. And this is a simple geometric object class which has the attribute colors, filled, like is it filled circle, filled rectangle, filled geometric object, and date created as attributes. And we have constructors and the default one with no parameters, with parameters, and get and setters and toString. After we extend from simple geometric objects, rectangle has add width and height and has the constructor to set width and height, as well as set and getters and get area, set area, as well as the circle also extend from simple geometric object, add the new attributes radius and constructor to set the radius and set and get radius and get area, get parameters and get diameters. And now we can come back to see how we use that as a polymorphisms. So we have a main method that has, we want to use polymorphism because we want to create just one method to display the object information. And this object information, we already know that they have the get date created form, simple geometric objects, and get color. So we don't need to redefine the method for each class, circle, and rectangle. We can just define one and make it as polymorphisms by using the super type as simple geometric object as the parameter of this object. And then for subtype, you can just pass in to call this method as the type of circle and type of rectangle subclass type. And the program still be able to run and show the appropriate output, like circle is red and rectangle is black. Because this is polymorphism, it can invoke the right method and give you return the right information of its own subtype. So that is the benefit of polymorphisms. You don't need to create two methods for circle and one for rectangle. You can just do one, which is called geometric object. Now let's look at polymorphism and dynamic binding and generic programming. Now let's look at, we create a class named polymorphism demo, and we create a method m, pass in different object type, but m is an object. We can do this too. Object is a super class for all Java classes, right? Graduate student, student, person. These are all subclasses of object. So this is polymorphism, right? Using object as the parameter of m. And of course, I can create new object itself to use that too. Its own class, right? So method m takes a parameter of the object. Then you can invoke it with any object. Now once we take the x in, we call it toString. And we look at graduate student class extends from student. So student is the parent, which is extends person. Person is the parent, extends object. And we see we override toString of the object by return person for person class, and student override toString of the person by return student. Now graduate student didn't implement toString. An object of a subtype can be used wherever its supertype value is required. This feature is known as polymorphism. So this is called polymorphism. When the method m is executed, the arguments x toString method is invoked. X may be an instance of graduate student, or student, or person, or object. And each class has its own implementation version of the toString. The question is, when we run this code for graduate student, which toString is it going to get invoked? Now, which implementation version of the toString is used will be determined dynamically by JVM, Java Virtual Machine at runtime. And this concept we call dynamic binding to see which toString to use. So dynamic bindings works like this. So if I have an object Cn extends Cn minus 1 extend from Cn, Cn minus 2 extend from Cn minus 1, and so on up to C2, and C1 extends from C2. And since O is an instant of C1, O is also an instant of C2, C3, Cn minus 1, and Cn. Now an object O is an instant of, right, C1 to Cn, where C1 is a subclass of C2 and so on, right? So C1 is the most specific class in this case. So in Java, Cn is the object class. If O invokes a method P, the JVM searches the implementation for the method P in C1 first. If we don't find it in C1, it's going to go look at C2 and so on up to Cn in order until it's found it. Once it's found it, the search stop and first found implementation is invoked. So that means grad student search for toString, not finding it. Then it's going to go to student. We found toString. Then in that case, it's going to print and return student at that point. And now for student itself, it's going to find student. It's also going to return student at that point. Now for person, so it's going to go and invoke person first to see implementation. Yes, so it's return person at that point. For object, it's going to return object version, which is the class name, polymorphism demo, add, and instance number. So let's look at when we run this application. So we get student, person, and the object, right? Which is the object class as invoked, so the instant object class name out. And this is called dynamic binding. Now let's look at the difference between method matching and binding. Matching a method signature and binding a method implementation are two issues. The compiler finds a matching method according to parameter type, number of parameters, and order of the parameters at compilation time. A method may be implemented in several subclasses. The JVM dynamically binds the implementation of the method at runtime. So there's a difference, right? Binding happened at runtime, but matching will happen at compilation time. Now let's look at what is generic programming. So polymorphism allows method to be used generically for a wide range of object arguments. We have seen that. So this is known as generic programming. If a method's parameter type is superclass, you may pass an object to this method of any of the parameter subclasses. Like if superclass object, then you can pass any, like grad student, person. And when an object is used in the method, the particular implementation of the method of the object that is invoked is determined at runtime, which is dynamic binding. So this concept that you are seeing we call generic programming. So to make program like more generically widely used, when you create a method like this, not specified to one object type. Sometimes we need casting to help, which we can look at this in the next video here.